Homework number 3 is due tonight. That's on your xyzhomework.com account. All right, I added an extra week to quiz 3. Only a few people had done the quiz, and there's no rush. We're just trying to get practice. So the new due date is the 28th. And then we'll start quiz 4 after that. So the first thing I want to check on is if anyone has homework questions. You can share them in the chat. We can work on them together. But I have some notes that we didn't go over last week, and then notes for quiz 3, and then new notes for the new homework. Okay, well, if you do have any questions, just let me know, and we can always stop and work through that problem. Okay, so a little bit more notes just for graphing. So if you want to put notes, some more notes for homework 3. So this is one way to graph a line that's in the y equals mx plus b form. Start with your y-intercept. And graph that point. I'm gonna graph the point where x equals 0, and if x is 0 here, y equals b. From that point, you use your slope. So whatever number m is, especially if it's a fraction, you go up the value in the numerator and then to the right, the value in the denominator. If you have a negative slope, you need to go down the value in the numerator, but still go to the right, the number in the denominator. Still going down the value in the numerator and to the right. I've got some examples. The first one is to graph y equals -3/4 x plus 2. Okay, first we're going to plot 0, 2. And then it's negative, so we need to go down 3 and to the right 4. Then you can keep on plotting more points, down 3 over 4 to the right. So you're starting at your y-intercept. Y-intercept has x equal to 0, and if x equals 0, y equals 2. So just something I've noticed in other classes is to make sure when you make units, try to space them out evenly. Let's start with 1, 2, 3, 4, 5. Okay, let's put this point 0, 2 right here. Then we're going down 3, right 4. That's set x equals 4, y equals -1. And then from here, you can go down 3 again to the right 4, but I just need 2 dots to create the line. This time we want to graph y equals 1/2 x plus, let's go with plus 1. X, y, and some units. It's right here at 0, 1. We're at 1 on the y-axis. We're going up 1, right 2. One space over. We can do that again. We could go up 1 more, then over 2 again. Last one for this topic. It's y equals 4x minus 3. Let's get this set up. And then we go to the point 0, negative 3. And then I need a numerator and a denominator. So what I could do is put this number over 1. It's still the same number. So up 4, right 1. From that intercept. I could create my line right now, but just to help draw it, I'm going to go up 4 again and over to the right just once. It's pretty good. It's a good enough sketch. Okay. Now I have notes to help you do quiz number 3. So I just want to mention that it is a part of the problem to find the slope, but you have to also use the slope in the equation for the line. So the first question, it says find the equation of the line. So it doesn't say finds the slope, it says finds the line, which part of the line is going to be the slope. And this line goes through the points. We're going to use 2, 5 and negative 8, 6. Oh yeah, for sure. You can totally retake the quiz. And if you have like 2 answers sitting there, for some reason, I will grade the correct. I will give you points for the correct part. So yeah, there are unlimited attempts on the quiz. And I will give you the highest score. Okay, we're gonna find the slope. Well, actually, let's put down what the line is gonna even look like. So you want to use something like y equals mx plus b. This is one of the formulas we talked about. It's my favorite. Okay, you need to know what this number m, and you need to get the number b. Then your answer needs to look like this, y equals mx plus b. Your slope is difference in y values and divide by difference in x values. You could use y1 minus y2 and match up that subscript with x1, subtract to x2. For this point, we're going to call the first the x coordinate x1. This is going to be y1. All this x2, y2. All right, we need to take 5 and subtract 6. Divide by 2 minus negative 8. In the numerator, there's negative 1, and it's over 2 plus 8. Negative 1/10. And I've mentioned this before, but just to make sure, as long as you have a negative sign in the numerator or in the denominator or in front of the number, it's a negative number. So we're going to bring it more towards the front. Okay, we know what m is. M equals negative 1/10. And we're using y equals mx plus b. So negative 1 over 10 x plus b. Okay, you can use either of your points. I picked the first point, 2, 5, but it doesn't matter which point you pick, you'll get the same answer. 2 is my x value. 5 is going to be my y. So I've got 5 here, negative 10 times 2 plus b. I'm going to keep the 5, and negative 2 is over 10, which we could factor. 10 is 2 times 5. Add b. And then the 2 over 2 is going to reduce to 1. So 5 is equal to negative 1 over 5 plus b. Add 1/5 to each side. And then we'll simplify whatever number b is. Okay, here, 5 plus 1/5 is equal to b. Oh, let's see. How did I get 5? Oh, no, you're fine. You're cool, you're cool. Yeah, it comes from the point over here. Okay, and then, but we're here with, we need a common denominator. So let's first, we're gonna put this over 1. Okay, let's just keep doing this. 5 over 1, we're going to multiply by 5 over 5. That way we have a common denominator of 5. All right, we've got 25 over 5. Add 1/5. And it's equal to b. Cool. Okay, b is equal to 26 over 5. So we take our value for b, and we take the slope m, and we put it all into y equals mx plus b. Okay, slope was negative 1/10. And we've got our value b, 26 over 5. Okay, if you need more help finding equations of lines, please visit office hour. And I'm going to go on to examples again for horizontal lines and vertical lines. For a horizontal line, you've got a variable, let's see, y, and it's equal to some number. A vertical line looks like x equals a number. Okay, we're going to do a horizontal line first. So let's find a horizontal line that goes through the point 3, -2. Okay, so I will we will graph this. Actually, maybe graphing will help with explaining. So let's go ahead and put a little graph on the side. Let's put this point down, 3, -2, over 3 for x, down 2 for y. Okay, it's horizontal, so we want it to go this way. So other points on this line would be maybe x equals some negative number, like -3, and then y would equal -2. Or x could be +5, but y has to equal -2. So you want to use the formula or equation of the line of y equals -2. And then we're just going to make sure that we highlight that line and we're going to label it. Cool. Let's find the vertical line that goes through the same point. So vertical line is going to go up and down. And let's start with plotting this point, and then we'll sketch a line vertically through it. Start with the point that's given. Positive 3 for x, negative 2 for y. It's pretty good. Maybe labeling it helps. Okay, and we want a vertical line. Here's that point. So if we check out another point that would be on this line, you could go up some number for y, like positive 2, but you have to go over 3 for x. So if you look at this point here, 3, 2. Our point down here would have x equal to 3 and y could equal something like negative 5. So here x always needs to equal 3. The line x equals 3, since y isn't mentioned, y can be any number. So y could be some number this way, but x equals 3. Or y can go down that way, but x equals 3. So that's your equation. For a vertical line. All right, one more part for talking about the quiz is to find x and y-intercepts. So if you, before I erase this graph, we can label that line. It's x equals 3. Intercepts of y equals 3x minus 4. Start with the x-intercept. You will put y equals 0. Y equal to 0. So 0 is here, and it's equal to 3x minus 4. Let's add 4 to each side. Divide both sides by 3. And x equals 4/3. Okay, but you want to put this as a point with your x coordinate first, the y coordinate second. So x-intercept is the point? 4/3. Now you need the y-intercept, so put x equal to 0. Y equal to 3 times 0 minus 4. So y is equal to -4. So I want to write this as a point. Your x value first, and the y coordinate next. Cool. Okay, so for the notes for homework 4, the first few problems that we're going to talk about, I posted a picture of them to the module for this week in Canvas. I'm also going to share them with you, but you don't have to write about, you don't have to write everything down. I'll write parts of the problem down, and again, the problem is in week 4 on Canvas. So there's still questions related to graphing, just kind of a little bit wordy. So I'm going to start off with important parts of the problem, and then we'll go read the question together and come back and solve it. So this is going to be section 3.2. It's number 87. We're going to have a formula with b equal to -45,000. T for time, plus 600,000. And that's a formula to give you this value, V. It's the value of a crane. Okay. So the variable V is the value of a crane. It's in dollars. This variable T represents time in years. Part A is going to ask, what is the value of the crane at the end of 5 years? Okay, so let me show you what I'm talking about. Okay, so over here on the left side, it's section 3.2, number 87. Over here, part A. So the equation V equals negative 45,000 T plus 600,000 can be used to find the value V of a small crane at the end of T years. What is the value of the crane at the end of 5 years? So find V if T equals 5. So we're putting in 5 right here. And I got V equal to $375,000. Part B is going to ask, is the crane, when is the crane worth $330,000? So they give you a value for V, and you need to go put that in and solve for T, that time that they're asking about. Okay, so we're gonna put 330,000 equal to negative 45,000 T plus 600,000. We've been practicing things like this. We just have larger numbers. We would subtract 600,000 from each side. Over here, I got negative 270,000. And we still have this negative 45,000 T on the other side. We'll divide each side by negative 45,000. So there we got our value t, and it's equal to positive 6. Okay. T was time in years, so I would write 6 years. Or after 6 years, the value of the machine would be 330,000. We're on part C, and it's asking, will the crane be worth 150,000 after 9 years? $150. Okay, there's different ways to solve the problem. What I'm going to do is let t equal 9 and then find v. If v equals this number, then yes, at 9 years it will have that value. If I put in 9 years to get some other value, then no, it won't be that amount. We'll probably state the amount that it does cost after 9 years. So t for time equal to 9 years, and into your formula, t equal to negative 45,000. Plus 5 with t. Add 600,000. I got v equal to 195,000. Okay, so since they don't match, we're going to say no. After 9 years, it's worth this much, not this much. Okay, part D asks how much did the crane cost? So if you ever have a problem that asks about the start or at the beginning, or when you first bought it, or something like that, you kind of need to choose the time equal to 0. So time in this case is t. And at time 0 is way back at the beginning, right? When you first purchased the crane, when you first started whenever you first started using, I guess, the object that's in the problem. T equals 0. Alrighty, so in the formula, that's like the only hard part, knowing what value to use for t. Then you just throw that in there with b equal to negative 45,000 times 0 for t, and then add 600,000. 0 times a number is 0. B is equal to 600,000. Okay, we are going to check out a problem from, I'm pretty sure it's 3.3. Well, let's just go there together. Ready? Here we go. Up here. 3.3, number 53. All right, Maggie has a job working in an office for $10 an hour. Another job driving a tractor, which pays $12 an hour. And she works both jobs to earn $480 in 1 week. We will write an equation that gives number of hours as X, the one where she worked for $10 per hour, and number of hours worked for $12 an hour will be Y. Okay, so they tell you what kind of variables to use, and then also tell you to create an equation. So X needs to be number of hours worked at the first job, which paid $10 an hour. Part A also says Y needs to equal the number of hours worked at $12 per hour. Okay, for our equation, we're going to take this X, the number of hours worked at $10 per hour, multiply it with that value, $10 per hour. And then add it to the number of hours worked at the other job, which paid $12 an hour. You don't need the multiplication sign, but it's just trying to make it clear. 10 times x plus 12 times y equals the totals that she earns, 480. Part B just asks for X and Y intercepts. Okay, we're using this equation that we just created. And let's start with X-intercept first. That's when you put y equal to 0. So 0 right here, 10x plus 12 times 0 equals 480. Times 0 is going to be 0. And then 10x equal to 480. Divide each side by 10. X equals 48. And for intercepts, I like to put them as a point. So your X value is 48 and your Y is 0. Y-intercepts, you make X equal to 0. Or you choose X equals 0. Okay, putting this into the formula, you'd have 10 times 0 plus 12y equals 480. Y equal to 480. Divide both sides by 12. And y equals 40. Let's write this as a point. X is 0, y is 40. Great. The next part of the problem asks to use the intercepts to graph the line in the first quadrant. See. Back to the picture. Okay, done part A, we wrote an equation. Part B, we got the intercepts. Part C, graph in the first quadrant. Okay, X, Y. Let's get some units ready. Check out our quadrants. This is quadrant number 1. This is quadrant number 2. Quadrant 3. Quadrant 4. Okay, so I need to be in this upper right corner. Use the intercepts, which are 48, 0. So let's label this 10, 20, 30, 40, 50. We'll go a little closer to 50 and call this 48. Put a point right there. That's your x-intercept, where this line crosses the x-axis. So actually, we're not going to cross because we're told to just draw right up to here and not over down into the next quadrant. And connect to 0, 40. Okay, that's it. And let's see, we're going to read part D, and then we'll come back to the board and translate what it's asking. We don't need to use the graph, but it asks, find how many hours she worked at $12 an hour if she worked 36 hours at $10 per hour. So first we're going to remember what our variables were. X was the variable for number of hours worked at $10 per hour. And they tell you this number 36 is equal to that. So 36 equals X. Find the value of Y, the number of hours worked at $12 an hour. So in 10x plus 12y equals 480. We're told x equals 36. And then we're asked to find y. All right, so if we have 360 times 12y is equal to 480. And subtract 360 from both sides. So I'm at 12y equal to, let's see, 0 minus 0, 0. 8 minus 6 is 2. 4 minus 3. Okay, so if 12y equals 120, we can divide both sides by 12. And y would equal, let's see, 20 is 12 times 10. 12 over 12 is 1. So y equals 10. Okay, last part, and it's the last thing we're doing for our meeting today. Actually, you can leave this up and okay, all the way at the bottom from the graph. Well, we're not going to use the graph, we're going to use the equation. How many hours, find how many hours she worked at $10 per hour if she worked 25 hours at $12 per hour. So y was the variable for hours worked for $12 per hour, and they say y equals 25. Find x, which is number of hours worked for $10 an hour. Okay, part E. Y equals 25. Y equals 25. Solve for x. Okay, so they'll tell you y is 25 and then ask you to find out x. Use the formula. Put in that number. All right, so I'm gonna get 12 times 25. That's 300. Keep solving for x, so we subtract 300 on each side. Divide each side by 10. Okay, x would be equal to 18. Hours. When we meet at our next class, I would like to do 2 more problems from chapter 3. And then we're going to go to chapter 4, which is systems of equations, and solving systems of equations. All right, thank you, everybody. Let's call it a day.